Okay, guys, so here's H-14. The directions are that you are given the graph of a position function x of t for a particle traveling along the x-axis. The output of the function tells you how many feet to the left or right the particle is from 0 at any time, where t is in seconds. Okay, so I've got to say a few things before we do this. This is my second take at this video. Okay, so just bear with me. I already filled in some of this. I meant to fill it in with you, or during the video, but okay. It's very similar to Susan's table. This is another table of information that we need to know. So usually x is like the original function, x prime, x double prime, position, velocity, acceleration. And then you can liken these to f prime, f double prime. And there is a lot of similarities between this table and Susan's table. Okay, but it's different because we care about different things when we're talking about particle motion, although they're related to the things in Susan's table. A particle is at rest when its velocity is 0. A particle is moving right or up, because we're usually, I think in AP Calc, we're always just usually dealing with we're dealing with like linear motion and usually like vertical or horizontal. I can't think of a time where I've seen anything other than that. Okay, so moving right or up, if the particle was doing that, its velocity would be positive. If the particle was moving left or down, we would know because its velocity is negative. If a particle changes direction, that's going to be a sign change on the velocity. Okay, so far we haven't brought in acceleration yet. Now with particle motion, when we're using acceleration, that's really when we want to answer the question, is the particle in the process of speeding up or slowing down? All right, and for that, I just have to do a little demo, guys. Okay, so we have here 4 situations. Here we've got an increasing concave up curve, decreasing concave down, decreasing concave up, increasing concave down. Now, in this context, we're dealing with velocity as the first derivative. So let's just say this is a part of the graph of a position function, which means that the first derivative or the slope of the tangent line on this graph at a certain point would represent would be its velocity. Yeah, so the velocity would be the slope of the tangent line here. So let's see at this point. At this point, think of the slope of that tangent line. It's positive, okay? It's positive. It's relatively steep. So we know that the particle is moving, I don't know, let's just say 30 miles per hour. 30 miles per hour. Now because this is a positive slope, it means that the particle is moving right or up. Okay, so the slope of this tangent line here tells us that the particle is moving, let's just say like positive 30 miles per hour. Positive meaning in a positive direction. Okay, well now it looks like it's moving maybe like, and I'm making these numbers up, guys. Maybe now we're going positive 90 miles per hour. Positive maybe 100 miles per hour. Positive 1,000 miles per hour. Okay, so we're moving to the right or up, you know, because we've got a positive velocity, but the particle is speeding up is my point. Okay, so here, so the slope of the tangent line is getting steeper. So here's speeding up. All right, the particle is speeding up. Now let's look at this case. All right, so let's look here. Now the slope of that tangent line, that's the velocity. Okay, that is the velocity. Now let's estimate the velocity. Very rough estimate. Let's say it's -20. Okay, so say negative 20 miles per hour. Well, what does a negative 20 miles per hour velocity mean? It means that we're moving at 20 miles per hour, but the negative is telling you that you're moving left or down. Okay, so the particle is either moving left or down 20 miles per hour. And then as we keep going, guys, the slope is just getting steeper. So negative 50 miles per hour, negative 100 miles per hour, negative 1,000 miles per hour. And it just, so again, the particle is speeding up. It's speeding up again. Now here, let's look. All right, let me look at this point. Okay, so I am just making these numbers up. Let's say that's like negative 50 is that slope. So negative 50 miles per hour. All right, so the particle is moving, all right, let's think of the x-axis. So the particle is moving left at 50 miles per hour. Still moving left, but at not, the slope is not as steep. So we're still moving left, but at a slower rate. Still moving left, but at a slower rate. The slope is getting less steep. Okay, the slope getting less steep means like slowing down. All right, so here slowing down. And then this one would be like a very similar situation. Focus. Okay, like here we're maybe moving like positive 60 miles per hour, so we're moving right at 60 miles per hour. But over time, the slope of that tangent line is getting less steep, meaning that the velocity is getting, less high. Okay, so slowing down again. All right, now, so what this means, guys, so if you have a situation like this, where the particle is speeding, you got two situations where the particle is speeding up, okay? A situation where the original function is increasing and concave up, and a situation where the original function is decreasing and concave down, okay? Increasing and concave up would mean f prime positive, f double prime positive. Decreasing and concave down would mean f prime negative, f double prime negative, right? So when we move to here, speeding up, if a particle is speeding up, that means that its velocity, the first derivative, is going to be positive. And the second derivative, okay, because that would determine concavity, would also be positive. So here we have the first and second derivatives having the same sign, both positive, or the first and second derivatives having opposite signs. Okay, so negative, negative. All right, so there's your two cases for when the particle would be speeding up. How about the particle slowing down? And I'll make a second video, guys. This is just an intro. There will be no exercises to go with this video. In the next part, I'll actually do this problem using the information I'm talking about. Now, slowing down, all right, slowing down. We have two slowing down cases, decreasing concave up or increasing concave down. So decreasing would mean f prime less than 0, concave up, f double prime greater than 0. And then slowing down, increasing concave down, so f prime greater than 0, f double prime less than 0. Okay, so here we've got the first and second derivatives have to have opposite signs. One has to be positive, one has to be negative in order for the slowing down of the particle to be noted. All right, so slowing down, we could have positive, negative, or negative, positive. Okay, so I'll make another video for the problem.